Okay, my young Padawans, today we are going to talk about equilibrium. I hope that in this first part I get to talk about dynamic equilibrium and the equilibrium constant. Okay, so what's the idea of equilibrium? We gotta remember or know that chemical reactions are reversible, but what does that mean? That means that a reaction may be in the phase of the reactants or in the phase of the products as long as the system is closed. That is very important to remember. The system must be closed. The position of equilibrium can be controlled by changing the conditions of this system. All right. Now, let's go very quickly to dynamic equilibrium. What does that mean? The forward and the reverse reactions can occur at the same time. That's what I meant at the beginning of this video. There is a part of reactants and there is a part of products, and it's coming up and coming back, so on and so forth. So it is actually they coexist, let's say. Now, as you can see in this figure, they refer to rates, right? Rates of forward reaction, that means from the products, from the reactants to the products, or rate of the reverse reaction, that means from the products to the reactants. Okay, so equilibrium is established the moment that those rates get to be the same. All right, now the concentrations of reactants and products at equilibrium are constant. Okay, that is very, very, very important to remember. The rates of the forward and backward reactions are equal, so that will take us to the equilibrium. Okay, now here we have an example, the decomposition of hydrogen iodide or the formation of hydrogen iodide by the reaction with hydrogen and iodine. All right. The figure shows this formation, right? We have the red line represents the formation of hydrogen iodide, and the blue line represents the concentration of iodine and hydrogen as the equilibrium is established. As you can see, they are proportional, right? But inversely proportional. Some of the info that we can get out of this figure is that eventually we will reach a maximum concentration, which is in this case 8.64 for the product and 0.68 for the reactant. So this figure refers to the formation of hydrogen iodide. But what about the decomposition of hydrogen iodide? We have this graph, this figure number 3. So how are they different? Pause the video and take a good look at it and figure out how and what makes them different. So we could say that the concentration of reactants and products are constant, but that doesn't mean that they are the same, that they are equal, okay? And actually what it happens in real life is that the equilibrium will lie to either one side of the reaction. What do I mean by that? It will lie either to the left or to the right of the reaction. That means that there are greater concentrations of either reactants or products at equilibrium. Now, let's remember that I said that equilibrium requires a closed system. And after you think about it, it's kind of logical, right? The system must be closed so you don't lose materials, you don't lose matter, you don't lose your products, you don't lose your reactants. And the way that we symbolize equilibrium is with a double-headed arrow, as we can see here on the screen. That represents the reaction at equilibrium.